All right, this is 6th grade, Unit 2, Lesson 9. And in this lesson, students are going to continue taking all of that information that they know about ratios and equivalent ratios and this new thing called double number lines. And they're going to be applying that to speed and figuring out constant speed and using those ratios to figure out how far or how fast they could go in, or how far they could go in a second, right? So let's get started. All right, the number talk is pretty straightforward today, so we're not going to dwell too much into the specifics, but the idea really, parents and teachers, is to help students with, developing their ability to do mental math. When we're talking about dividing by powers of 10 or multiplying by powers of 10, we want to be thinking about stuff more thoughtful and mathematical than just you move the decimal. All right, because really, when we're thinking about it, we're really moving the digits in the place value chart. We're not actually moving the decimal. The decimal just kind of looks like it's moving. For example, if I go, okay, here we go. Here's my tens, my ones, my tenths, and my hundredths. Let's start there. So if I want to model, what does 30 divided by 10 mean? Well, 30 divided by 10 means I would have 3 tens. So let's get a little bit thicker there. 3 tens, 1, 2, 3. And if we want to divide by 10, all right, so each of these dots is worth 10 ones. So I can cash each of these dots in for 10 ones. So this dot right here gives me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then this dot can be cashed in for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then this dot can be cashed in for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then if we are dividing by 10, so we had to take these 30 dots and group it into 10 equal sized groups. Well, what is that going to look like? Well, each group is going to be 3 dots. 1, 2, 3, 4. And my dots were not perfectly drawn. 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3. There are my 10 equal groups. So 30 divided by 10 equals 3, because each group equals 3 dots. So look at that. 30 divided by 10 equals 3. And so really, if you're thinking about it, it's the digits, these 3 dots, got kind of moved over into equaling 3 dots in the ones column. So you could kind of think of it as really it's the digits that are moving. In this case, their digits are moving to the right because we're always dividing. Wow, that was more than I was expecting to talk about. But have fun with this, because the key is we need to help students develop mental math. So parents and teachers, this is a really fun way to introduce constant speed. We're going to give students the opportunity to actually do the walking and generating their own data that we're going to use later in the lesson. And the idea is they're going to start here, and now they're getting into some real nice nitpicking stuff that I appreciate. So what they're saying is, let's get this out of the way. All right. So what they're saying is, students are going to start here, even though the word says start here, and that's how they're going to ramp up to their constant speed. And then from here to here is 10 meters, and they're going to be timed, once going slowly and once going quickly, working in partners, and just to generate their own data. This is a really wonderful way to get students engaged in the math that they're doing. It also addresses the question of, when are we ever going to use this? Well, you're doing it right now. Here, this is the answer, so that we can figure out constant speed. So that's the idea. Just, you're going to do it once at a slow speed, record your data, and then you're going to do it once again moving at a faster speed, and you're going to record your data. And once you've got that data, you're going to do some math with it. So it says after you finish collecting the data, use the double number line to answer the question. So moving slowly. So you traveled your 10 meters at some speed. I mean, in some number of seconds, right? So I don't know. Let's just pretend, and I'll say it's 8 seconds. We're just making up the data right now. And then let's say the next one down here, moving quickly. Let's say you ran really quickly and you did it in 3 seconds. So I'll put 3. So you're 10 meters in 3 seconds. Now it says estimate the distance you traveled in 1 second when going slowly, and do the same thing for when moving quickly. So basically what we need to do is we need to take our double number line, and we need to do math to figure out 1 second, all right? So I like that cutting in half until it doesn't make sense anymore idea. So I'm going to cut my seconds in half to get 4, which means my distance will be cut in half to give me 5. I'm going to cut my time in half again, which gives me 2, which cuts my distance in half, so I get 2.5. And then I'm going to cut my time again in half, and that gives me 1 second. And when I cut my distance in half, I'm going to get 1 1/4. All right. All right. So that was pretty easy. I conveniently chose simple numbers. All right. It's not going to be quite so simple now. So now for moving quickly, we've got 3 seconds. So I could cut in half, but in this case, what I think I'm going to do is I'm going to divide by 3. Because if I take my 3 seconds and divide by 3, that's going to give me 1 second. So what am I going to do with my distance? Well, I'm going to divide it by 3. And so when I do 10 divided by 3, I get 3 1/3. And that's how I did it. I just simply took my 3, divided by 3 to give me 1. So I'm going to take my 10 and divide by 3, and I could get 3 1/3. In fact, that's a trick I can always use to get my unit ratio. Take the number, divide by itself, take the other number, and divide by that same first number, and that's how you get that unit ratio. So now that I've got it, I can start, I can trade my diagrams and all that sort of stuff. But parents and teachers, the point of this part of the lesson was really to just allow students to do math with some numbers that might not be totally friendly, totally textbook friendly, and allow students to grapple with real life data. So we're going to do a more traditional textbook problem here. It does have an app, a GeoGebra applet, that you can QR code. I'm not going to use it. I'm going to go old school. To be honest, just that this app just isn't speaking to my heart. I like the old school drawing the double number lines myself. But go ahead and try it if you want. It's pretty good stuff. So we have Lynn and Diego. They both ran for 10 seconds at a constant speed. Lynn ran 40 meters and Diego ran 55 meters. Who was running faster? Well, we kind of obviously know, since they both ran for 10 seconds, Lynn ran 40, Diego ran 55 meters. That means Diego was running faster because he ran further in his 10 seconds than Lynn did in his 10 seconds. So we know that it was Diego who was running faster. So then the question is, how far did they move in 1 second? And if you get stuck, consider drawing a double number line. So the idea is I am going to draw a double number line just to really hit it home, the importance of that double number line. And so with, let's see, Lynn, and actually what I'm going to do, I don't know if I should draw, no, let's do a double. So here, let's take care of Lynn right here. And it's 0 and 0. And actually when I do 0, I want my 0 to be here. So we're going to say this is distance, and this is seconds, right? And this is for Lynn. Then we're going to do the exact same thing for Diego. So we've got a number line, another number line, and that's 0 and 0. This is seconds, and this is distance, and I know my writing is horrible. Deal with it. Okay, and so that's Diego. Oops, black, go away. Diego. All right, and so now what we've got is in both cases, they ran for 10 seconds. So we're going to put 10 seconds right here, and we're going to put 10 seconds right here. And then we're going to put in Lynn's information, which is 40 meters, and then we're going to put in Diego's information, which is 55. So Diego is 55, Lynn is 40. And if we want to know how far did they run in 1 second, well, here's our 1 second right here. Here's our 1 second. And so the idea is, well, how do we take this 10 seconds and turn it into a 1 second? Well, we got to divide by 10. So I'm going to take that and divide by 10 to get down to 1 second. So what am I going to do with the 40? I'm going to divide by 10. Oh, now we're seeing the connection to the number talk. And 40 divided by 10 is 4. So we're going to do the same thing with Diego. So 10 divided by 10 gives us 1 second. So 55 divided by 10 gives us 5.5 seconds. So parents and teachers, you're starting to see the wisdom of those number talks. That number talk was directly connected to the math that we're going to be doing today. How beautiful and thoughtful is that? That's pretty darn cool. That is really cool. Hey, but by the way, we have more proof. In 1 second, Diego ran 5.5 meters. Lynn, in 1 second, ran 4 seconds. So now we could compare our own speed. In the previous slide, in fact, here it is. Look at that. So cool. Use your data from the previous activity to compare, right? So we can do that because we've got that unit rate. That unit rate when we converted everything into 1 seconds, or a non-unit rate when we're looking at everything in 10 seconds, makes it really easy for us to compare our own speeds with Lynn and Diego's speed. But in this case, if we wanted to know who was faster, we would look at the unit rate with 1 second. But here it says we could go the other way, and we could take our old data and scale up to figure out how far we could travel in 10 seconds. I'm gonna spare us that because I'm gonna let you do that on your own. So it says here, Han ran 100 meters in 20 seconds at constant speed. Is this speed faster, slower, or the same as Lynn's and Diego's and yours, right? So the idea is we're going to need to think about putting Han on a double number line. So here's my double number line, and here's my zeros, and this is my seconds, and this is my distance. Now Han ran 100 meters in 20 seconds. So if we wanted to, we can kind of whittle our way down. 10 seconds is 50 meters. But really, we could just do that giant leap down to 1 second. How are we going to do that giant leap down to 1 second? We're going to divide by 10, which means we're going to divide the 50 by 10, and that gives us 5. And so now that we know how far Han traveled in 1 second, it makes it easy for us to compare Han's speed with Lynn's and Diego's and even your own speed. So wrapping up our lesson, really it's that power of the double number line, that appreciating the unit rate right here, where in this case we're talking about meters per second. We've been talking about that. How far can you go in 1 second? And thinking about that giant cosmic leap. How do you go from 5 down to 1? In this case, you would divide by 5. And that gives you your giant leap down to 1, which means that's how you're going to do your giant leap for your distance. We would divide by, I might have said the wrong thing. Take your 5, divide by 5 to get down to 1. So your giant leap to 1 is divide by 5. So your giant leap here is you take your 100 and divide by 5. And that's really the power of today's lesson. And in this case, we've been talking about meters per second. How far can you run in a single second? And that was the key. So let's do some practice. And I'm not sure if I'm going to do all the problems today, but because it's all pretty straightforward, right? So we got, well, let's just jump straight down to number 2. So a scooter travels 30 feet in 2 seconds. And so they've conveniently given us our double number line already. What is the speed of the scooter in feet per second? Well, that means we want 1 second, which means since we took our 2 and cut it in half, we've got to take our 30 and cut it in half, and that means we have 15 feet in 1 second. And then it says complete the double number line to show the distance after 1, 3, 4, 5. Well, we already did 1. Now, if we want to know 3 feet, a couple of ways we could do it. We could either take, 3 seconds. We could either take 1 second times by 3, and then we take our 15 and multiply by 3. Or we could add 1 plus 2 to get 3, so we could add 15 plus 30 and get 3. So a couple of different options. In both cases, we're going to get 45. And I'll show you one, which is 1 times 3 is 3. So 1 second times 3 gives us 3 seconds. So 15 feet in each second times 3 gives us 45. To get our 4 seconds, well, I'm going to think of it as take the 2, double it to get 4. So take the 30, double it, and you get 60. Now, how are we going to get the 5? Well, I think in my case, I'm either going to take the 1 second times by 5 to get the 5. So I'm going to take the 15 and times by 5. And what is 15 times 5? 75. There you go. And so we just did A, we just did B. Now question C. A skateboard travels 55 feet in 4 seconds. Is a skateboard going faster or slower? Well, all we have to do, we don't have to do any math. All we have to notice is this ratio right here. 55 feet in 4 seconds. And we can see that the scooter is traveling 60 feet in 4 seconds. So the scooter is going faster than the skateboard. So this problem is really the same as the previous problem. It's just more practice trying to find that unit rate. So we got a cargo ship traveling at 150 nautical miles. How far did it go in? And here's the key, in 1 hour. So we see our 6 hours here. So we want to make a cosmic leap, a jump, big giant leap down to 1 hour. So how do you go from 6 to 1? You divide by 6. So what are we going to do with our 150? We're going to divide by 6. And 150 divided by 6 is, oh my goodness, I'm doing the math here, 25. Woohoo. And so we know that that cargo ship can travel 25 nautical miles in 1 hour. Just more of the same, only this time we're going to answer a couple of questions with our double number line. So I'm going to quickly make our double number line, and that double number line looks like this. And here's my 0, here's my 0. Now, let's see, we're going to do eggs down here, so I'm going to put eggs. And then, what's this one? Oh, flour. This is flour. All right, so we've got eggs and flour. There's our zeros. And it says a recipe for pasta dough says 150 grams of flour per large egg. So we know our unit rate right here. They gave us our unit rate. We've got 150 grams for 1 egg. All right, and that's this right here. So the question is, how much flour is needed if you have 6 eggs? Well, if we're going to have 6 eggs, so that's 1, 2, 3, 4, 5, 6. Here's our 6. So what did you do to go from 1 to 6? Well, you multiplied by 6. So what are we going to do up here at the top? We're going to take that 150 and we're going to multiply by 6, and that's going to give us 900. Oh my goodness, so 900 grams of flour. We don't know, that's a little less than a kilogram, I guess, but nobody has a sense of what that is. It's about 2 pounds. So anyway, how many eggs are needed if 450 grams of flour are used? So somehow we need to say, well, here's 150, so that makes this 300, because all I have to do is add by 150. All I have to do is add by another 150 to get 450. Add by another 150, that gives me 150. Add by another 150, that gives me 750. And then add by another 150, that gives me 900. So we're adding by 150 each time, because what's going on is, well, we're adding by 1 egg each time. And each time you add an egg, you have to add 150 grams of flour. And now we can see our answer is right. Oopsies. I accidentally erased. Undo. And let's go here. And here is our answer. How many eggs are needed if 450 grams of flour are used? We need 3 eggs. All right, this is just more of the same. It's the only difference is now we're dealing with decimals, so you might want to consider using a calculator to do your money. But the idea is we're going to make our double number line. Here's your 0, here's your 0. And in this case, we're going to talk about maybe bags down here. We're going to talk about money right here. And the initial ratio they give us is 4 bags. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 2, 3, 4 bags. 1, 2, 3, 4, 5, 6, 7, 8, 9. 4 bags is $11.96. So we know that this line right here is $11.96. So now how are we going to do our 1 bag? Well, we're just going to divide by 4, and that's going to give us 1 bag. So what are we going to do? We're going to do a cosmic leap and divide by 4, and that's going to give us the cost of 1 bag. And that's right here. Cost of 1 bag. And then once we know that cost of 1 bag, it's really easy. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's really easy to figure out the cost of 9 bags, because all we have to do is take that 1 and multiply by 9 to get 9. So we're going to take our cost and multiply by 9, and that's how we're going to get the cost of 9 bags. So this is more of the same, and I'm not going to solve it. The only thing I'm going to point out is we're talking about cats right here. But you'll notice the double number line is talking about ears and paws. So we don't really, while the number of cats is important, what we're really keeping track of is ears and paws. So you're not really necessarily going to see 1, 2, 3, 4, 5 in your number line, because we're keeping track of ears and paws. So there's your heads up on that one. All right, this one's a little bit of a review. It's talking about equivalent ratios from back in the day. And we're supposed to explain how do we know, explain for each pair, explain why they're equivalent ratios, and draw a representation that shows why they are equal. So 5 to 1 and 15 to 3, why are they equivalent ratios? So I'm gonna start by drawing a ratio of 5 to 1. So here's my 5, 1, 2, 3, 4, 5, and here's my 1. So if I want to know how do I prove that the ratio of 5 to 1 is equal to 15 to 3, well, all I have to do is take each of these and cut them into 3 more pieces, and so that 5 becomes 15 and the 1 becomes a 3. So 5 to 1 is equal to 15 to 3. And we could do that same process on each of these. Draw a picture, subdivide them to equal that new ratio. And we could do, now what are you going to do for this one? Ooh, that's gross. But I think you could figure it out. How do you simulate drawing all these subdivisions over here? All right, and that wraps up. Let's see. Well, there we are. That wraps up. Let's see what grade 6, unit 2, lesson 9, using those double number lines to find constant speed and the unit rate in like meters per second or feet per second. If you have any questions, send me an email, send a comment down there. All right.